Okay, very good afternoon to everyone. Welcome to our Excelpoint webinar on ultra-low power vital sensor solutions for wearable and hearables. My name is Chin Len. I'm the field application engineer for Excelpoint, in charge of the sensor products and providing technical support for the customer. So I'm also your moderator for today's webinar, where we will get insight on the latest sensor technologies for powering smart health devices. Today, we have three speakers that will be joining us, bring with them more than 50 years of cumulative industry experience and knowledge covering for engineering, supports, marketing, and business developments. First up, we have Mr. Chang Kwang-woon. He's the product marketing manager for Excelpoint. Second will be Mr. Jong Won. He is the field applications manager for our principal MS Osram. And last but not least, we have Mr. Tan Yew Boon. He's the sales director for our principal Ambiq. Before we begin today's sessions and hear from our speaker, please feel free to ask questions. You may click the Q&A icon at the bottom on your screen and type your questions in the chat box. We will answer your question at the end of the webinar. Okay, now I will play our Excelpoint corporate video. Please relax and enjoy. Thank you.
Every day, our lives are connected through the Internet of Things. Driven by innovation, Excelpoint is making future technology possible.
Established in 1987, Excelpoint provides the latest semiconductor technology to the customers and enable the customers to deliver their products in a faster speed to the market.
We work closely with our principals, creating innovations to complement and enhance our customers' products and solutions. With a proven track record in digital signal processing and unparalleled wireless connectivity, Excelpoint strives to be at the forefront of wearable devices. Our dedicated team of engineers aim to improve our customers' operational efficiency and cost competitiveness. In the fields of industrial automation and energy management, our smart sensor solutions allow facilities to run preemptive equipment maintenance. Even at home, we are opening the gateway to seamless control, bringing features and applications together. Over the years, our network has spread, establishing a presence in 50 cities in over 10 countries. With a diverse workforce of over 650 employees across our specializations. Setting our sights on the horizon, Excelpoint aims to be an international pioneer and the driving force towards bringing the future closer to today. Excelpoint, empowering future technology.
I hope you all have enjoyed the video. Okay, welcoming our first speaker of today, Mr. Kwan. He has over 10 years of experience in semiconductor, covering ASEAN and energy regions with background in engineering, field application engineering. We hand over to you, Kwan.
Thanks, Jinlan. Hi, everyone. My name is Kwan, and I am the PM handling sensor product lines and MCU in Excelpoint. Wearable and hearable segments are evolving rapidly, not only on the market demand, but also on specification and features. These include the healthcare function, which will remain top priority for developers in coming few years. Before we go deeper to our topic today, allow me to share with you briefly on product or solutions that Excelpoint can offer for wearable and hearable. What you can see on the screen now is some key technology you will be able to find in wearable products. Let's start looking at the sensors. The position sensors, namely gyroscope, help track the angular movement. Example, by lifting your wrist, your watch face will turn on. An accelerometer helps detect human motion, whether you are walking, running, cycling, or sleeping. Barometric pressure sensors measure the absolute air pressure, so you will know your altitude level, and by monitoring the atmospheric pressure changes, it can also tell us about the weather. Due to COVID outbreak, vital sign sensors such as heart rate monitoring, blood pressure monitoring, oxygen level, and temperature sensing has now become key focus of most developers. Many already looking to meet medical grade accuracy, whether you are in motion or not. Later, John will be able to share with you more on this area. Next, we look at wireless connectivity. We are seeing the trend is moving to SoC, system on chip solution. But for customers who prefer separate wireless chip or module, we do carry all these product lines. Some application, especially on the payment, you may also need crypto or authentication solutions. For power management, we are seeing the trend that using PMIC or power management IC, one that is small size and high efficiency of at least greater than 90%. Better still, if the PMIC comes with integrated wireless charging solution. Halo has a very good product on this. Finally, the most important piece of technology will be the core processor. With so many sensors now integrated in wearable, and we are looking at wearable that can last at least over a week of battery lifetime, the processor must be very power optimized to run all the algorithms and also have very good standby current. Today, one of the great solutions we can bring to you is Ambiq Micro. And in the later part of the webinar, Yew Boon will share with you their unique technology and why Ambiq Micro has remained top selection of many key wearable brands. Next, I shall move to hearable solution. What you can see here is a general block diagram of TWS solution, which breaks into a cradle design and the earbud design. Starting at the cradle design, today the power management is moving towards a single chip PMIC solution with wireless charging. So the wireless charging has to be smaller size and optimized cost for the BOM. Halo has a very good solution which I would like to highlight here today. On the screen, I'm showing you a TWS solution done by Excelpoint R&D. You see how simple the cradle design is. First of all, there's only 3 main chips. The main PMIC HL7090, the over voltage protection HL5093, and WPC wireless receiver HL6111. In fact, the MCU is also optional, and you can remove it together with the buck converter and the LDO for very simple design. You can now look at the internal block of the HL7090. It's directly charging the earbud from the integrated boost converter and charging the single cell lithium-ion battery from integrated charger. And the PMIC also has the interface to the Hall switch to detect lid closing on the cradle. Halo new HL7 series PMIC is even more impressive. As you see, it shows even more integration with built-in wireless receiver of WPC 1.2, 1.2.4 standard. So if you're interested to find out more about Halo solution, please feel free to reach out to us or leave a comment in the survey end of the session with your contact method and questions. Next, if you look at the earbud design, we see the trend now that active noise cancellation has become standard feature in most TWS products released out to the market this year. If you recall that past few years, ANC only appeared on very high-end, expensive hearable product. So the golden question for hearable now, what would be the next growing trend and how do we increase the battery life of TWS earbud but not increasing its physical size. Also, if you do a quick check on the internet, you can read many articles talking about smart health sensing and intelligent voice command. Heart rate sensor integrated earbud can continue to monitor your heart condition while you are engaging in various sport activity. Next, we are even looking at sensor to detect the body hydration. So with earbud design getting physically smaller, there's also limitation of button or touch area. Why not we think about using a voice command to activate some function and keep a very simple, clean design on the earbud to improve the overall aesthetic look. And with more sensors and algorithm to run on the earbud, we need to have a very small size MCU that able to operate at very low power consumption. When we say low today, we are really talking about just a few microampere for every megahertz of MCU operating frequency. Today, in this webinar, you will be able to hear from our next speakers all the great products and solutions that they have prepared for you. Before I hand it over to the next speaker, John, I would like to end my session by playing a short video to share with you a new subsidiary company by Excelpoint called PlanetSpark to enable and help our customer to bring their AIoT hardware solution out to market faster.
Our world is built on ideas, powered by connectivity, and ignited through understanding that sparks innovation in all of us.
Nurturing the next digital revolution is what PlanetSpark is all about. It is the first dedicated hardware accelerator in Singapore, bringing startups to the forefront of technology.
With this new PlanetSpark Innovation Center and Program Initiative, we see there will be a stronger collaboration effort. This excites me. In fact, I believe in this technology. Data is growing very fast, and in the near future, the demand for faster communication is needed.
To have a sustainable advantage, we chose sensors that can operate in the invisible spectrum. Not only PlanetSpark shares the same vision of the need of thermal sensors in the marketplace, it helps us to connect with their customers, be it OEM or system integrators.
Our goal is really to develop cutting-edge computer vision technologies, build middleware using our software. There, the possibilities are endless. Hardware is not an easy space to break into. Having someone with extensive knowledge of hardware as a partner is very useful for us.
For over 30 years, Excelpoint has formed strategic partnerships with global semiconductor manufacturers, expanding its networks and regions. This makes Excelpoint the best foundation for PlanetSpark to help startups to develop technologies and achieve commercialization.
PlanetSpark, connecting innovations to reach markets.
Thank you so much for sharing, Kwan, for the information for the wearable and hearable. Indeed, there are so many considerations are unique to developing smart health tech products. So if you have any questions for our speaker, you can use our Q&A functions located at the bottom of the screen to ask or pick questions you wish to speaker to answer. So right now, we would like to invite our next speaker, John from MS OSRAM. He has over 20 years of experience in application field, specializing in optical sensors applications. Over to you, John.
Hello, good afternoon, everybody. I'm John from AMS. Osran, and I'm in charge of technical support to the customer. So today I will here to present you the beta site monitoring product from AMS Osran. So today's agenda basically is two parts. First part is the heart rate monitoring sensors. So we are talking about the discrete solution, integration solutions, and design consideration, and also the application example and evaluation case. The second part is the other sensors, like temperature sensor, ambient light sensor, and UV sensors. Also, I will spend a little bit time talking about the market trends. So AMS Osran as a group company, now we have a 5.5 billion revenues, and we have more than 5,500 engineers, including product R&D and application engineers. Worldwide, we have 30,000 employees, and for the market segment, we are 60 to 40. So basically, AIM, we are about 60% of our revenue, and consumer is about 40% of our revenue. And we have 40 plus R&D location because during the last few years, we acquired quite a number of the company, and they have a R&D center spread all over the world. That's why we have different locations. Okay, and we have 50,000 patents grants for the products. So AMS vision is to become a sensing, illumination, and visualization leader. So the product profile from AMS, basically we have an emitter. So it means LED, micro LED, visors, and lens. Then we have detectors. We have a light detector. We have biosensor. We have image sensor. Then something in between is optical parts. So we have a module, optical modules. Then we have a micro lens, DOE, all this kind of product. Then beside that, we also have an integrated circuit to drive the emitter and to drive the detectors. So AMS market share, basically, we have address in the consumer market, automotive market, industrial market, and medical markets. So for the consumer market, we are focused on 3D sensing, face recognition, gesture recognition, display management, gamma enhancement, IR, VRs. For the automotive, we focus the in-cabin sensing. We have a ADS system. We have a adaptive cruise control. We have a LiDAR, and we have of course, we have a rain sensor, kick sensor, and night visions. For the industry, we have image sensors, is high resolution, high speed image sensor. Then we have automations, 3D sensing, LiDAR, stroboscopies. For the medical, we have an image sensor, we have biosensor, LFT, and we also have a health monitoring. So today, my product, the product I present is under this health monitoring category. So what is a vital sign monitoring? So basically what you see, there's 3 kilometers what we are monitoring now. If you went to any hospital, you see the body, they are monitoring the patient's body temperatures, heart rate, and pulse oximetries. Now, we see the new trend is coming. So the people want to using this kind of vital sign to monitor the blood pressure, sleep apneas, cardiovascular events, or body hydrations, etc. So we currently have product for these 3 parts: body temperature, heart rate, and pulse oximetry. We are working on the blood pressure, sleep apneas, and body hydrations. So what is the location for the vital signs? Basically, anywhere in your body, from head to toe, from fingertip to your arms. So the popular location, what we see from our customer product now is put in the finger, or in the wristband, or in the arms, or in the chest, or in the ears. Now, what we see is getting popular. Again, the popularity is in ear here. We have a lot of earbud. They have embedded this heart rate monitoring, SpOT measurement in that earbud. Okay. How does biosensing work? It's quite simple. So the LED shine out the light, and then the bright wizard reflect back to the photodiode. Because the bright is moving around the bright wizards, so we get a different signal level to the photodiode. From there, we can get the PPG signals. So pulse oximetry is also a simple solution. So you see these two lines here. One is the red line. It means the bright carry the oxygen. The blue line here, it means the bright without the oxygen. So what we do is we're using the two LED. One is the red LED, the other is the infrared LED. So the red LED is about 600 nanometer, and the infrared LED is about 900 nanometers. So what you see here, in the 600 nanometer areas, the red line here, they have a big absorption. So it means that with the oxygen has big absorption on the 600 nanometers, but less absorption on the 900 nanometer. Opposite, the without the oxygen, you see there's a less absorption on the 600 nanometer and more absorption on the 900 nanometers. So in this way, we can calculate the proportion between these two in the 600 nanometer and 900 nanometers. So from there, we are able to get the SPO2 levels. So the building diagram, the block diagram for the Vita side front end, basically we combine the three parts. There's LED, PD, and analog front ends. So there's a two-in-one module. It's so-called the LED plus PD. So it's so-called the optical front ends. So it's LED plus PD. Then we have a receiver front ends. It means a PD plus analog front ends. So it's two-in-one here. And we have three-in-one. So all three parts in one packages. So AM is for all of these three products. Just give me a second. I get the point out. Okay. So the Vita side solution for AMS, we have a discrete solution. We have two-in-one. We have a three-in-one integration solutions. So what we see here, discrete solution, we have a green LED, we have a red LED, we have an infrared LED. Then we also have a modules, two-in-one modules. It means that red and infrared is, and we have three-in-one modules. So it's a red, infrared, plus the green LED. So three-in-one LED in one package. Then we also have the another PDs. So it's a discrete PDs. So we have a different in size with the different filter on top of the PDs. Then we also have the analog front end. So analog front end is nothing more than the driver IC. So it's a driver the LED, it drives the PDs, and it also have ADC inside and some buffers. So AMS have a discrete solution. So we have a LED, PD, and analog front end. Then we have two-in-one solution with so-called optical front end. So it's a 7070 and 7072. So it combines the LED plus the PDs. So what we see here, 7070 is one PD with a two LED, one IR LED, one red LED. And the 7072, we have a three LED and two PDs. So three LED is a green, red, and IR plus the two PDs. And in the middle, the PD with the IR cuts. Then we also have a PD plus analog front end. So we are talking about the S7030A, R, and G version. We have two versions for that, for the different applications. So then we have three-in-one. We have LED, PD, and front end all in one package. So both sides, we have a two LED in the both sides, and in the middle, we have PD and analog front ends. So for the analog front end, basically, I mentioned before, it's nothing than a driver. So it have a PD driver. It can drive up to the 6 PDs. And then it has LED driver built inside that. We can drive up to 8 LEDs. Then beside that, we have a 90-bit ADCs built inside the circuit. Of course, this chip here, we are able to support the ECG. Normally ECG, you need a very low noise analog front end here. So as AMS, we have a very experience in the very low noise and very low power analog front ends. So we have built this is a medical grade and ECG analog front end we have built in the chips. The other one is 7038. So this is a 2-in-1 modules. So basically there is a PD plus the analog front ends. So also include the 4 LED drivers. So G here is stand for green. So it only support the green LED. So from block diagram here, you can see this IC, we can support up to 4 LEDs. And we have a we have a PD with the green filter on top of it. Then beside that, we also have a ECG, medical grade ECG front end built in. So from Spectra here, what you see here, we have a filter on top of that. We only allow this visible green light to pass the chips. In this way, we can increase the signal qualities. We don't get the interference, anything beside of this green bands. Okay. Then we also have an IR LED on top of IR filter on top of that. So what you see, we have a 2 filter on top of that. So the next product we are talking about is a 7038R. RB. So R is for red. Okay. So this means R is using for the majorly using for the SpO2 and sleep apneas or oximeter. Okay. So what you see here, again, we have 4 LED drivers. Okay. And then we have PD and we have put the red filter on top of the PDs. So what you see here is we only allow red and IR to go through to our chip. So the other bands we are brought outside. So in this way, we can increase the signal qualities. Again, we have put the medical grade ECG inside the chips. So this is another one. So now come to the LED selection guys. So rule of thumb, how do we select LED for the heart rate monitoring? Normally we're using the green LED because green have a better penetration to your skin levels. Okay, then for SpO2 measurement, we need 2 LEDs. We need a red LED and IR LEDs. Then AMS offering, we offer 2-in-1 or 3-in-1 LED modules. So for the 1715, we have a red LED and IR LED built in one chips, okay, built in one modules. And then we have a 1716, we have a 3 LED built in one modules. So it means that we have green, red, and IR LED. Then beside that, we also have a discrete LED. So discrete LED, we have a green LED, we have a red LED, we have an infrared LED. So what you see, red LED, the central frequency is about 657 nanometer, and infrared is 940 nanometer. And you also notice all the V4 voltage here is less than 3 watts. So it's good for you to use together with the lithium battery without any power management, just direct connect our LED to the lithium batteries. That's all you need. Okay. Okay, then the next one is the photodiode and optical front end. So beside the LED, we also offer the photodiodes. What you see here, we have a different size of the photodiodes. And we have you can see the different color on top of that. This means that we put a different filter on top of that. Like a different 2713, you have IR cut. It means that we cut out the IR proportion. So we only let the visible light to go into our sensor. In this way, we can minimize the IR interference. So we have a small PD. We have a 0805 like a 2700. So this is small. So for your application like earbuds, you might need this one. And we also have green enhance. Green enhance means that we use green to monitor heart rate monitoring. So we put on top of the green filter on top of that to enhance the green proportion to go into our chips. So this is good for heart rate monitoring. So then beside that, we also have optical front end. We combine the LED and PD together in one module. Then we have a first generation one, we have a second generation one. So the second generation one, we have a 70-70. This means that we have PD plus 2 LED. This is one is red LED, the other is infrared LED. So this cater for the SpO2 monitoring. The other one, we have 3 LED here, green, red, and IR, and we have 2 PD here. So it means it's catering for the heart rate and SpO2s. So now go to the arrangement of the PD and LED. If you choose the LED and the PD, now how to arrange it? This kind of question. So normal, the people doing is arrange, they put the PD in the middle and LED on both sides. So in this way, you get the flexible on the design, and then you can put the barrier in between the LED and the PD. So in this way, you get a better signal noise levels. Or the other things, you want to improve your dynamic measurements accuracies. So you need to put a PD. So you put the LED in the middle, then you need to put the PD on both sides of the LEDs. In this way, you will increase the signal noise level for the dynamic heart rate monitoring. So wherever you want to do the dynamic heart rate monitoring and you want to get a better accuracy, then the more PD is needed. So the second one is for the heart rate and SpO2. So normally you have 2 PDs. One is for heart rate measurement, one is for the SpO2 measurements. Then in the middle, you have 3 LEDs. You have IR, red, and infrared. Okay, this is a concept of how you do it. But in reality, the people that we have put a more PD on the both sides. Let's say it's 4 PD. So the same goes for the dynamic heart rate measurements. You want to get a better signal quality, then you need to use this one. Or the people using 6 or 8 PDs. So the more PD you use, the better signal you can get. And then you can monitor different position and you compare the signal quality, then you get a better one and you do the algorithm on that. You do the algorithm based on that. So from here, what you see, we have a different color code of the PDs. So we have different sizes. We have a different field on top of them. Then the second question, when you choose the path, then how to improve your SNR, because everybody, the end front end is critical for the signal chain. So wherever you do good in the front end, then you are best, you will very easy to do your algorithms. So the front end, basically, we have a LED, we have a emit part, we have a receive part. So for IMS, we have a different LED color of the LED. We cater for the different applications. And we can set the different driving currents through our analog front ends. So like your dark screen, you need a more current to drive in order to get a better signals. Or you can put a more LED, you increase the number of the LED for getting a better quality for the different screen colors. Then come to the PD side. So we have put a different filter on top of the PD just to increase the signal levels. So you see we have blue enhanced, we have a blue enhanced PDs. So we just let the blue band go through our PDs, and we have a green enhanced PDs. We just let the green band go through our PDs. The other bands is cut off. So, and we also have IR cut, just let the visible band come to our CD. And of course, to get a better signal for the dynamic heart rate monitoring, you need an increased number of the PDs. So this tool is quite easy. You by setting the right path and you by setting the right configuration, you can easy to do it. But here is come to the critical part. Between the LED and PD, we need a optical design. So the first key parameter is air gap. What we see here, we see lots of customers, they have a large air gap and they have very low quality, they have lots of crosstalk, they have a very low quality noise signals. That's why the algorithm is very hard to do with it. So in the beginning, we always suggest to minimize air gap as small as possible. So the rule of thumb here, from our past experience, 0.5 millimeter is the maximum you can do it. So we prefer around 0.2, 0.3 millimeter air gaps. Then glass thickness also plays a big part on the signal quality. So rule of thumb here again is 0.5 millimeters. Okay, 0.5 millimeter, if we are balance the robustics and also the signal qualities. Of course, the thinner the better, but because too thin, they're easy to break up. So you need a certain thickness. So 0.5 is a good number for that. So besides that, the LED and PD, LED might direct coupling to the PD. So we need a barrier in between the LED and PD. So there's a barrier between LED is needed. So material of the cover glass, this means the transmission. So if you block too many light go through the chips, go through the PD, then it's a problem. So we need like a high transmission right to the PD. Okay, the material you use. Then beside that, there's other thing like an ambient light. Ambient light because for hardware monitoring we're using the green light. So it's a visible light. So the ambient light has a big portion of the green light portion here. So we need to block this light. Then we need to do this ambient light cancellation. With AMS solution, we already have built in this function in the chip. You only needed to do is just configure the register. You want to enable it, disable it, and how large you want to do the cancellations. Okay. Then the next one is algorithm improvement. So you can the last step you go for the algorithm improvement. Maybe you add a more filter, okay, digit filter, or you using the fast Fourier transform to analyze frequency, and then you take out the proper signal. Okay, this what we see from our customer designs. Okay, then there's some algorithm from AMS also. We so-called the selective is mean we don't have algorithm for all paths. We only for the certain paths. So here we have a two paths. We have algorithm. We have 3-in-1 module 7030, and we have 2-in-1 module 7030 ARG versions. We both have the algorithm for that. But bear in mind, we only have static hardware algorithms. So it means we only doing a static hardware monitoring algorithm. We don't have a dynamic one. So the dynamic one, you need to develop them by yourself. So basically, we can offer is a hardware library, okay, hardware monitoring library as requested. And we need to sign the NDA and SLA, okay, software license agreement, SLA. Then we have fingertip SPL2 algorithm. This one, again, we only can provide the library funds, and we need the NDA and SLAs signed. Okay. So now come to the application example. Of course, there's no count all the combination. I just share some of the combinations. So for the fully integration solution, if you don't have much about the optical design and optical knowledges, you might choose this one, 7030. The fully integration solution, we have take care of the optics design, everything in one chips. So from here, what you see here, you have two LED on both sides, and in the middle, there's a PD. Okay, and the front end. So wherever you just connect a microcontroller through the iPhone I2C, you can read out the heart rate data. Okay, for the semi-integration solution, we have the optical front end plus analog front end. So 7072 or 7050. Combine this together, you have a semi-integration solution. Then you also have a discrete solution. So it means you have a LED, discrete LED, discrete PD, and optical front end here. No, sorry, this one is so actually it's a 7050 here. So it's the analog front ends here. So the last one here, we have a LED, we have a PDs, and then we have the analog front end. So I just give you that some of the combination. So from here, you have an idea how to pick the right part for your applications. So the next one will be the SPO2 measurements. So for the semi SPO2 semi integrator, so basically you have the front end here, you have LED, both LED here. Okay, PD plus the PD plus the analog front end here. Then you have two LED, one is red and one is infrared LED. Again, here we have a LED modules. Inside you have a red and infrared LED. Then you have a discrete PDs plus the analog front end. So then this one here, we have an optical front end plus the analog front ends. Then the other one here, we have the 7060 is means the three LED both in three LED in one module. So and then you have PD and analog front end. So in this way, you can do the hearable monitoring SPO2 measurements. So here's one of our reference design. So because we are talking so many choices, so many different choices. So and then we need to build one circuit to approve to customer. We are able to do it and the circuit is working fine. So we have to do the reference design, but only hardware available, not algorithm. So this reference design here, what you see here, we have four PBs, 42703 and 42713 PDs. Total is IPD in one packages. And then you see these are four green LED in the package. And then we also see in the middle, there's two LED modules. It's a 1750 is inside, they have IR and red LED inside. So total is 8 LED plus 8 PDs, okay? And the other side, we have a 7050 analog front ends. And beside that, we also have this kind of motion sensor from the ST is here. So LIS2DH12 is here. So for this module here, we don't sell this module, but if you need it, we can provide the schematic. We can provide the Gerber file. You can manufacture by yourself. So for here, we just only pull the concept. We make the hardware working, so you can do your own software development. So again, highlight here is we are not selling this part here. We only provide the reference design. We can give you the schematic. We can give you the Gerber files, but not selling the complete module here. Okay, then we have another one is we so-called evaluation board. It's a 7050 evaluation board. So basically we have 7050 IC here, and then we have an electrode here for the ECG measurements. Then we have the analog front end here, optical front end. So you put it here, you can put it in here or take it off, or you can connect the different designs. Like we have this total, we have an IPD 5 LED in this reference design here. So basically, then we also have freeze. So for this, we are setting this evaluation board for you to try out the chip functions, and you can do the evaluation on our chip performance, especially on the ECG and the signal quality. And you also get familiar with our chips. You can set a different register. You can play around with a different register setting through these different tabs. Okay, then this end of my hardware monitoring sessions. The second session is other sensor. So AMS provided temperature sensor, ambient light sensor, and UV sensor for the wearable applications. So the temperature sensor here, we are the medical grade temperature sensor. What you see here from 20 to 42 degrees, we are talking about 0.09 degrees. We are the first one in the market offer such high accuracy temperature sensor based on the silicon. Okay, then the power consumption is very low. We are talking about 6 microamp, 4 samples per second. If you think they are still too large power consumption, then you can reduce to that. Like 1 minute, 1 samples, then you can reduce the power consumption to the 1 microamps, and the size is very small. We are talking about the 1 something by 1 millimeter. So it's very tiny modules. And the good thing here, we are easy to use. So the next slide, I will show you how easy to use. So what you use here, for the temperature sensor, you need to do the calibration. So basically, the algebra, what you've done before, you need to do the trial and error, you need to collect all the data, and you spend a month and months to fine tune the algorithm for the calibration. But with IME chip, you don't need to do anything because we do the linearize and calibration in our factory. So once come out of factory, then you already got the data or the calibration data. You don't need to do by your own. You just readd and add up the offset the calibration data. Then you get the temperature readings. So it's so easy to use. You don't need to do all this headache job to do the calibration, to do the linearity, or all these things. Also, the other good feature here, we are able to program the alert function. So what you need is you can set a deep 4 level of the alert function. So 1, 2, 3, 4. So you can set this side of the when the temperature reach these ranges, that will give you the alert. So or you can program reach to this range or this range or this range. You will give the alert to your microcontrollers. So for this one, you can save the power consumption. And the other thing is we have I2C address. So it means that you can program for this chip here, you can program up to I2C address. It means that in the same board, you have put up to the temperature sensor in one box. So you don't need to worry about you run out of I2C interface. So how do we do it? We have 2 pins here, okay? We have address pin and VDD and VSS pin. So these 3 pins combination, we are able to do the 8 different, we are able to set in the 8 different I2C address. So for more detail, please refer to our data sheet. So what is our supporting material? So basically we have a data sheet application node, we have Linux reference driver, and we have a Eurasian board and demo kit. And this demo kit is a Bluetooth demo kit. So this is a temperature sensor, and we have a Bluetooth module built inside. So you can connect to your mobile phone and directly read the temperature out of phone, this small button here. So beside that, we have a design guide. So the design guide, we show you how to do the thermal design guide for the PC reference designs. So from here, what you see is how we put the IC and how we do the PCB designs. So what you see here, you can see here and how you get the better temperature accuracy through the proper PCB design and thermal designs. So for all these documents, you can download from our website, ms.com/621-. Okay, then next one is ambient light sensor. So ambient light sensor is quite simple. It's just sensing your ambient light. So inside that we have 2 channels. We have one is the full channel. It means that we can pull the full ambient light. The other is IR channel. So because we want to cut off the IR interference. So with these 2 channels, you are able to cut off this IR portions, give you a better accuracy of the ambient light reading. So this chip again is very small, 2 by 1 millimeters, and the height is very small. It's a 0.5 millimeters. So this is our ambient light sensor. The next one, we will go to the UV sensor. So what you see for the solar spectrum here, you can see there's a certain amount of the UV spectrum here, UV energy here. So you see there's a UVC, UVB, and UVA energy in your solar spectrums. So how does this spectrum reach to us? So normally you have an oxygen level. So the ozone level will block the UVC. Then portion of the UVB and UVA will reach the Earth. So what is the problem of the UVA and UVB? So for the UVB, it will cause you sunburns. So for the UVA sensor, it will cause you skin cancers and the wrinkles. So in this way, we need to monitor UVA and UVB levels. So here we come, the AMS have a UV detect sensor. So we are all able to provide a UV index to the customer. So basically we provide a UV index to the customer. So from here, we have a UV light channel here from 310 nanometer up to 400 nanometer. And why is not UVB here? Because basically from the UVI portion, we are able to get the estimated UVB portion. Then from UVI and UVB portion energies, we are able to calculate the UV index. So for this chip here, you can see we have a UVI sensor, we have an IR, and then we have a photodiode. So this PD in here. So this is only the UV sensor. It also serves as an ambient light sensor as well. So what you see here, the PD here, you can see this purple color, this two purple color is a UV sensor, and this red color one is IR sensor, and this cyan color is our normal photodiode. Okay, so here we also have an ambient light engine built inside the chips, and from here you are able to set the different input limits. Then you can give the interrupt output, and the data can be sent through the I2C to your microcontrollers. Okay, so how good you can see from our chips performance. So this blue one here, what you see here is the sunlight spectrum. Okay, and this red here is this red PD here is our IR PD here, and the green response here is our normal PD here, and the purple color PD here is our UVI sensor here. So what you see, we have a quite good signal here. So basically we can get about the 20 per lux for the UV sensor. Okay, then we're talking about a little bit about the market trends. So the market trends here, we see that the people now move from integration solution to the discrete solution because it's a flexibility. You get the customer need a more flexible on the ID designs that can put the PD and LED in a different location to get a better performance. So that's why that lots of people now, that lots of customers is choosing the discrete solutions. Then before we only monitor PPG, now ECG, we see there's become a lot of standard configuration now. Because lots of companies now implement the ECG to their smartwatch or wearable device or the wristbands. And also SPOT is getting popular now. So what we see here, before we only do the ATCOM monitoring, which means that you just on and off, you want to monitor and then you turn on, you don't want to turn off. Now we see that lots of continuous monitoring is required, especially for the chronic disease. They need the continuous monitoring. Then the last trend is not only the single sensors. Before only the heart rate monitored sensor. Now they put the temperature, UV posimeter, and also the other sensor like glucose sensors as well. So to give the to get a more data out from your body. So this is what we see for the marketing, and all the AMS also product also move in this direction. We offer more and more sensor for the Vita sites, and we have doing the very low power products. So for this continuous monitoring, we have a EGC front end built in the chip in our analog front ends, and with a discrete LED and also the PDs. So just to recap, so we're talking about the LED, we're talking about the LPD and analog front, all these discrete solution. Then we have this kind of integration solution, 2-in-1, 3-in-1 optical design input of the SNR for the applications. Then we have talking about the other sensor like temperature sensor, AR, UV sensor. Then we talk about EVK and selective algorithm. I hope this will give you some better understanding AMS product and product profile. Thank you. Okay, then back to Chilin.
Thank you so much for sharing, John, and providing us relevant updates trend of the wider size sensor solutions. I believe customers always want to know about how to select the correct sensor for their applications. So if you have any question for our speaker, John, you may use our Q&A functions to type in your questions. Okay, and joining us next is Yew Boon. He has 27 years of industry experience with a solid background in international sales and business development. His role now at Ambiq is focused on growing the wearable and IoT market segment in Southeast Asia. We hand over the floor to you, Yew Boon.
Okay, thanks, Jinglen. Hello, everybody. Nice to meet you all. My name is Yew Boon Tan, and I'm the Sales Director from Ambiq, located in Singapore. I want to thank Excelpoint for inviting me to share Ambiq's vision and solutions in the Smart Health Sensor Solutions for Wearables and Hearables webinar. So let's begin. Health has always been a concern for everyone. In an article from McKinsey & Company, it indicated that by 2025, just in Asia, there will be 456 million seniors aged 65 and above, and this represents 10% of the total Asia population. We are looking at 14% growth in the next 4 years in Asia itself. Hence, the demand for health services, healthcare, wellness, and most importantly, also preventive measures to keep us healthy will be very crucial. While investments in hospitals and physician health infrastructure will continue to rise, technologies related to health and wellness has been the primary driver in pushing forward the recent development related to preventive measures. Developers explore ways to implement monitoring systems without the need to carry heavy monitoring equipment along with us. Developers start to explore what most people carry along on their day-to-day activities. And this is where we start to see smartwatches, activities tracking bands, and even hearables like earphones, TWNs, and headphones have health sensors designed in to monitor our health vital signs. Before COVID, to consumers, features like heart rate monitoring, blood pressure monitoring, SpO2 monitoring, sleep monitoring, etc., in wearables like smartwatches are something, well, nice to have. Accuracy and having long battery life is not a must for consumer, since it is just a lifestyle type of products. After COVID, consumers realized that they could turn to, example, their smartwatches to help them keep them safe and their health in check. Manufacturers quickly caught on with this trend and introduced new and smarter watches, wearables and hearables, with more functionalities that are health-centric. As the wearables and hearables continue to collect a huge amount of data, devices need AI to help analyze the data and turn them to insights. These insights, in turn, help to advise users of the wearables or hearables if he or she needs to seek medical advice immediately. Hence, the information collected needs to be as accurate and sufficient as possible, as I believe no one wants to visit the doctor unnecessarily. And there's also the consultation cost when visiting a doctor. With all the processing of data and AI, the next challenge for developers is power. Majority of the wearables and hearables products are battery powered, and most of the time, they are powered by small size battery. As most of the processors or controllers are power hungry, developers face the dilemma of choosing between performance and power efficiency. If the product has very short battery life, consumers will need to constantly charge their products, and as a result, health data collected might be limited. The solution is to find a very low power processor or controller in the range of few microampere per megahertz during active time. Imagine if you can design more features or functions into your product, but maintain the same battery power, or keeping the existing features and functions, but extend your battery life. This is where Ambiq can offer you the performance you need without sacrificing power. With our Spot platform, we can effectively lower the compute to run at sub-threshold and reduce the total power consumptions by more than 10 times of the normal range. So, who is Ambiq? I believe a lot of the participants in this webinar might not have heard of Ambiq. Ambiq is the industry-leading provider of microprocessor for battery-powered IoT endpoint devices. It was founded back in 2010, focusing on building the world's most energy-efficient solutions for battery-powered endpoint device. We have the vision to put intelligence everywhere. We are able to achieve low power through the core technology known as sub-threshold power optimized technology, or SPOT in short. We have been growing double year over year since 2017, and even last year, with the global COVID pandemic, we almost achieved double revenue growth again. Our founder and also our CTO, Scott Hansen, was a professor in University of Michigan, and he was doing some research on low power technologies 4 years before Ambiq was found. With the new technology he has developed, he decided to commercialize it, and that is where Ambiq was found in 2010. Based on the SPOT technology, we successfully launched our first product, RTC or real-time clock, in 2012 and sold the first 1 million units by 2014. With the success in our RTC, we launched our first MCU product that is based on ARM Cortex M4, known as Apollo. It is 10 times lower in power than the lowest power MCU available in the market at that time. And within a year, we sold 1 million units of Apollo. As a small company like Ambiq back then, to achieve first 1 million units of MCU product sold within a year is considered pretty good. Since then till now, we have launched a total of 4 generations of MCUs SoCs. Our second generation MCU, Apollo 2, the active power consumption is 10 microampere per megahertz, while our third generation, Apollo 3, consumes 6 microampere per megahertz. With IoT and endpoint AI in mind, we have integrated BLE with our Apollo 3 and Apollo 4 MCU to form SoCs. There are several major global smartwatches and fitness band companies where we are in all their platforms since we first designed in to their products. How Ambiq MCU's SoCs achieve such low power? In the conventional digital circuit, from most MCU suppliers, to differentiate a 1 and a 0, you need 1.2 volts. Our SPOT technology allows us to achieve the same result based on 0.3 volts. We are looking at per transistors in MCU. In an MCU, it has thousands to millions of transistors, and hence, you can see the amount of energy that is saved. We have been recognized in the industries with several awards, with the recent awards such as the 2021 AI Excellence Award, BIC Innovation Award, IoT Semiconductors Company of the Year 2021, and Most Innovative AI Applications. The latest is our 4th generation SoC, which is also being recognized as record low energy efficiency. We work closely with our strategic partner, TSMC, who is the leader in the wafer technology, and we were featured in their CSR report, and our core competency is also being mentioned in their wearables tech report. We were one of the 3 companies being showcased at the TSMC 2021 Tech Symposium. Ambiq is still in a growing phase, And as of now, we have about 155 employees worldwide. The interesting part is that right before COVID, our total employees worldwide was only about 90. So since COVID till now, we have increased about 40% headcount. Our head office is located in Austin, Texas, in US, and this is also where our IC developments are done. We have a sales and support office in San Jose too. In Asia, we have 2 offices in China, one in Shanghai and another in Shenzhen. We also have an office in Taiwan to cover both Taiwan and Korea, plus operation functions. Our latest expansion is in Japan. For me, I'm based in Singapore, covering ASEAN, India, and ANZ region. So where is Ambiq's products being used in? We have been very successful in the wearable segments. 9 out of 10 of the major global smartwatches and fitness bands companies uses Ambiq to achieve longer battery life without sacrificing performance. Health sensors no longer just place in smartwatches or fitness bands. The trend is also moving towards adding health sensors in hearables, since lots of us uses TWS or headphones while workout or during daily activities. Ambiq products are used as a sensor hub for both wearables and hearables. We also have success in the smart home segment, where the trend is moving towards battery-powered and also voice command. Remote controlling your TV, sound system through voice command without the need to push a button. How does that sound? While playing your game, using your console buttons and having haptic feedback, you can also issue a voice command to activate certain functions of your game. Something like you are talking to Jarvis in the Iron Man movie. Will that be a great experience? We are also in the smart industry segment where applications require battery powered. Here are some of the recent key initiatives that we are moving towards. On wearables, we talk about adding intelligence, and you need not have to worry between battery life and performance. Our MCU SoC can be used as sensor hub in the wearables, which I have mentioned in my previous slide. 9 out of 10 major global smartwatches and fitness bands companies uses Ambiq. The next coming trend on wearables and hearables will be voice command. Why is that so? Let's have a quick look at the market trends before and after the COVID first. Then we will look into the voice command trend in the wearables and hearables. Health has always been a concern for everyone. As healthcare improves over time, the next focus is on preventive measures to keep us healthy. Technology related to health and wellness has been the primary driver in pushing forward the recent development. Before COVID, we have credit cards which still required some form of contact for security purpose when it comes to high dollar value purchase. Smartwatches and bands are something nice to have for some people. We have remote control and keypads or key locks that are still contact-based. After COVID, in the digital health area, we need some form of contact tracing to trace potential COVID clusters and stop it from spreading. Wearables with health sensors and AI to provide early warnings and personal health monitoring is picking up at a much faster pace. On the touchless area, to increase security and reduce contact with others by having biometric sensors on credit card and access entry. Using voice control through wearables and hearables to replace keypads and buttons. Voice command have been implemented in mobile phones since 2010. There is Siri for iOS and Alexa enabled mobile phones. However, for smartwatches and bands, remote controls, TWS, gaming controllers, and smart sensors. Not many of such applications implement contactless voice command features. So you still need to at least press a button to activate voice command. What's the reason? Well, to implement contactless voice command, the system has to be always on to wait for the wake word or command. Most MCUs in the market are power hungry. And to implement always on voice command will drain the battery life very fast. Imagine you can activate your smartwatch to switch to running mode without navigating through your watch and without the need to press a button. Telling your TWS to answer or reject an incoming call while you're running and listening to your music instead of figuring where to press a button to answer or reject a call. Ambiq, with the ultra low power technology, is able to run high performance processing with sufficient memory at the right price to support always on voice command in all these applications. How about you sitting comfortably at your sofa and control the TV channels or volume with the ease of voice command? Some might say, well, that is a good to have feature. What about a patient on the hospital bed who he or she is not able to move and want to switch the TV channels or volume up and down or even turn off the TV? He or she is able to do that without anyone's help through voice command. What about an elderly person who falls in the toilet and no one is home or around, still conscious but not able to move to reach the emergency button? He or she is now able to say, example, "Hey Ambiq, call emergency," through his or her smartwatch or wristband or some form of wearables to seek for help. Wouldn't it be nice to just tell your smartwatch to call your friend while you're running, or tell your player to play what song while you're exercising without stopping to select the music you want? With Amazon's new security requirement for Alexa coming in September 2021, Ambiq's Apollo 4 Blue is ready to meet all the requirements. The Apollo 4 Blue voice kit is able to support analog mic input for machine language inference, make phone calls, flexible audio connectivities, etc. Our voice on spot kit consists of Vesper or MEMS sensing digital microphone or Invensys analog microphone, microbus shield, Apollo 4 Blue EVB for hardware. For voice processing software, you can work with DSP concepts for signal processing and sensories or retune for wake word detection. There is opportunities for always-on voice applications in wearables and hearables device, but power is the main barrier. Ambiq Spot provides the needed power efficiency, processing power, memory size, and competitive pricing. Ambiq Voice Kit, or Voice on Spot, known as Voice on Spot, is the tools that will assist developers to develop always-on listening, local commands, and voice-to-cloud applications. Developers can leverage on Ambiq's power advantage and form factor to create lots of new use cases and ideas. If you'd like to know more on our voice solution, get in touch with Excelpoint. You can leverage on Ambiq's very low power MCUs SoCs to develop the next generation battery-powered IoT endpoint devices with either more functions without sacrificing on power, or with same functions but a longer battery life. Ambiq will continue to grow rapidly into intelligent personal devices with voice solution. Ambiq will diversify into smart homes, industrial automation, and mobile health devices market segment. Ambiq will also develop products for AI platform and strengthen current products derivative. Stay tuned for our next generation products supporting AI platforms. With that, I thank you.
Thanks, Yew Boon, for sharing the Ambiq solutions. Because of this COVID-19 pandemic really caused a big shift in how smart health tech solutions are being deployed. And for customers who want to bring smart health tech product into the markets, one of the most important considerations is power consumptions. See, many of the smart health tech rely on the battery power endpoint devices. So now we have to come to the end of this webinar. I appreciate if you could give us your feedback through our server form at the end of our webinar. So I would like to thank everyone who made time to participate in this webinar, and a big shout out to our speaker for sharing their knowledge and thought leadership on the technology solution for smart wearable and hearable devices. So if you have any questions or you would like to know more about the technology solutions such as reference design and the power development from MS OSRAM as well as from the Ambiq, so please let us know, or you can reach us to me and from the speaker. We have typed in our respective email contact in the chat box. So I hope you all have enjoyed the webinar and we can stay in contact for future activity by Excelpoint. Thank you very much, everyone, and we appreciate your attendance. Thank you.